Today I'm going to be playing around with an Arduino microcontroller board and a servo. This particular board right here is the Arduino Leonardo model. This is an authentic version and I got it from Amazon for about 25 bucks. You can get these cheaper though because Arduino is an open source hardware project. Therefore, there are a lot of different manufacturers who make these boards. I just personally kind of like to stick with the OEM stuff and support the Arduino community directly. The servo motor I got from Micro Center, as you can see here, for $10.99. This is a 3-piece set. The brand is Inland, and it's just the blue 9G servo motor here. So let's go ahead and take a look at the Arduino board itself. I chose this particular model because it has the headers already installed, as you can see. The black risers here with all the pins really clearly marked. And one cool thing about the Leonardo is that it has an onboard micro USB port that can power the board. So you can power this thing with any 5-volt source. You can plug it into any kind of 5-volt power supply that you have, or you can just plug it directly into a computer USB port. As long as you have 5 volts of power, then this thing will run. It does also have another input for power right here, but I do not plan on using that for my particular use case. If you don't know anything about the Arduino microcontrollers, these things are really awesome. They run a very simple programming language and they can be used for all kinds of stuff, from just running LED lights or triggering servos to triggering pretty much any kind of external hardware that you may have around. You can do really anything you want with these project boards. They are absolutely awesome. I am not an Arduino expert or anything like that. This is actually my first project working with one of these, and I'm pretty excited about it. So let's go ahead and take a look at the servo itself. This is a very simple and cheap servo. It is not high torque. It's just your run-of-the-mill plastic gear servo. It comes with the motor, which is this right here. And it comes with these plastic connectors that you can screw to the top, and you can customize this for whatever use case you may have for it. So pretty much all servos, they have 3 wires coming out of it. This one has this female connector at the end. The brown wire at the top is the negative. The red wire, of course, is the positive, and the orange wire right here at the bottom is the PWM control, which is pulse wave modulation. That is the wire that the microcontroller actually uses to send the control signals to this thing and tell it what to do. So normally you would need to have header pins, which are male-to-male pins that would connect these two. But in this case, to connect a servo to this microcontroller, we're going to have to get some wire leads, and we're going to have to actually extend these pins out. So for example, we're going to be sending the negative wire to the ground pin right here. The positive is going to go to the 5-volt pin under power. And then for the other PWM control wire, it's going to depend on what your code is. The programming code is going to tell it what pin to use on this other side. So we'll take a look at that here shortly, and then we'll get this thing plugged up and see if we can get it working. The first thing that we'll have to do is go to the Arduino website and download the Windows software package. This is going to give us the utility we need in order to write, compile, and upload the code to the board. One of the coolest things about Arduino is that it has a massive community behind it online. So for the servo sweep code, I'm just going to go Google around and find somebody who's already provided one. Then we'll just tweak it to our needs. In this case, I just searched Google for Arduino servo sweep and I selected the very first link that came up. I will go ahead and provide that link in the video description for those of you who want it. So here I'm just going to copy the code that I found here, and then we'll just paste it into the Arduino utility that we will use to upload the code to the board. So now that I've downloaded and installed the Arduino software, I'm just going to paste that servo code into the sketch window. Before we can upload any code to our board, we'll need to go under the Tools menu and make sure we select the correct board model that we're working with. So in this case, I'm selecting the Leonardo model. Now we will compile and upload our sketch to the Arduino board. You should see some amber lights flashing to indicate that it's communicating with the board through the USB port. All right, so now we have the code uploaded to the microcontroller. We can just go ahead and disconnect it. Now it's time to cut some wire leads so we can hook up that servo motor. I'm going to be using 26 gauge wire that you can see right here. We're going to be cutting 3 equal lengths of this and then stripping it. After you strip the wire, it's always a good idea to just twist up the ends to clean them up. So once again, I'm going to be tapping into the 5-volt power pin on the board. I'm also going to be tapping into the ground pin on the board. And for the particular code I'm running, it's using pin number 9 on the PWM side over here. So pin number 9 is where I'm going to tap in. Now, of course, you would never want to hook it up this way for a project, but in my case, I'm just doing some experimentation, so this should work fine. So pin number 9 on the PWM side is going to go to the orange wire on the servo. Five-volt power is, of course, going to go to the red wire on the servo. And then the ground will go to the brown wire. All right, so let's go ahead and hook this thing up to power and see if it runs the servo. The microcontroller has a bootloader on it, so as soon as you apply power, it should run the code that we just put onto it. And there we go. The servo motor, as you can see, is sweeping back and forth with no delay. I will need to make some changes to the code because the top secret project that I'm working on is actually going to require this to have a delay going back and forth. I probably should have mentioned this earlier in the video, but I will be uploading an Arduino project that's pretty interesting here in the near future. So this video really is just me experimenting with the use of the servo and trying to see if this will work for what I need it to do, and I think it will. So just something to remember about powering the servo from the microcontroller is that you are only supplying 5 volts of power to the microcontroller itself, which in turn is supplying power to this servo. So if you had more than one servo, or if you have a project where stability and reliability is extremely important, then you would definitely want to have another power supply for your servo motors. But in my case, as long as it sweeps intermittently, then it's going to be doing the job that I need it to do. But I just wanted to make a quick note on that. So a lot of Arduino people, they may be cringing at the thought of just running the servo from the board. And honestly, in my case, I don't really care too much about that, but I did want to make a note. I'm going to make some changes to this code to better fit my needs. The first thing I'm going to do is change it from doing 180 degrees to only doing 90. Then I'm going to put a 10,000 millisecond delay, which is 10 seconds, into the middle of the code. That way it sweeps in one direction 90 degrees, it waits 10 seconds, and then it sweeps in the other direction 90 degrees. So I made some changes to the code that makes the servo move in a 90-degree position instead of 180. It also has a 10-second delay in between the movements. This is more along the lines of what I'm trying to accomplish with my project, and it seems to be working pretty well. So as you can see, every 10 seconds this thing sweeps back and forth 90 degrees. And that's pretty much it. It was an extremely simple process to get this thing programmed and get the servo motor to do exactly what I needed to do. Be sure to hit the subscribe button to stay in the loop on my future uploads. I will be uploading a new video in the next few weeks that has both of these things put to use. It's going to be a really interesting and fun project that I'm working on.